Okay, welcome to your second lesson for Unit 8. Again, Unit 8 is all about quadratic functions. In the lesson from last week, we just learned how to identify a quadratic function, so what makes something quadratic or not. Now we're going to start getting into how to solve quadratic functions. We're going to be learning 4 different methods of solving functions. In this lesson and in the next video, we're going to be using square roots, so basically just inverse operations to solve our equations. So you can see that our do now is just asking us to review what we did in Unit 1 with square roots. So I'd like you right now to pause the video and try to answer these 2 questions on a separate piece of paper. Okay, so for the first question, the square root of 4, there are 2 answers here. Again, you always ask yourself what times itself gives me 4. And there are actually 2 different numbers that can work for that. We can either do 2 times 2, or we can also do negative 2 times negative 2. So our 2 answers here are 2 and negative 2. But don't forget, a way that we learned that you could write that is by using the plus or minus symbol. So we can write plus or minus the square root of 2. Now, when we come over to the square root of 12, there are no numbers that when I multiply it by itself, that gives me 12. So that means that 12 is not a perfect square. So instead of just saying, okay, I can't simplify this, the other thing we have to think about are the factors of 12. So if we list out the factors of 12, we have 1 and 12, 2 and 6, and 3 and 4. Now we ask ourselves, are any of those factors perfect squares? And we see that 1 is a perfect square because we can do 1 times 1, or 4 is also a perfect square because we can do 2 times 2. After we've identified all of the perfect squares, we pick the largest of those perfect squares, which in this case would be 4. So we're going to be focusing on 4 and 3. So what we do now is we come back to the square root of 12, and we're going to split this radical up into those 2 numbers. I like to put the perfect square first, so I'm going to write the square root of 4 times the square root of 3. Mathematically, I haven't really done anything yet because 4 times 3 is still 12. But I know from the first do now question that the square root of 4 can be simplified to 2, and it can actually be plus or minus the square root of 2. So our answer here would be plus or minus 2 square root of 3. That square root of 3 just drops straight down. So we're going to need to use this knowledge of simplifying square roots as we get into solving our quadratic equations. So you can see our learning target for this period says I can solve simple quadratic equations by using square roots and isolating the variable. So right now you're going to need to use the packet that says Solving Quadratic Equations Part 1. This lesson is going to be on page 3. So if you need a minute to go get that packet or just a separate piece of paper, please pause the video to do so. So reading at the top of page 3, it says a quadratic equation is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. There are a number of methods that can be used to solve a quadratic equation. Simple quadratic equations of the form ax squared minus c equals 0 can be solved by taking square roots. So you can see that all the equations that we solved today are going to look like this. Ax squared, so some number times x squared minus some other number that they're calling c equals 0. So right now I'd like you to take a look through example 1. So read through the problem that they gave you and all of these steps here and try to answer the 2 think right pair share questions. So please pause the video and try that on your own. Okay, so looking at our first question, it said list the steps performed to solve for x. So all of these were using inverse operations. So if I had to summarize all of this all together, I would say that this person used inverse operations. However, let's just try to break it down step by step so we know what they did. The first thing that they did is they added 8 to both sides. 8 is the number that was furthest away from the x squared, so that was the first one they moved by knowing that the opposite or the inverse of subtracting 8 was to add 8 to both sides. The next thing that they did was they divided both sides by 2 because they saw that they had 2x squared, so 2 times x squared, and that inverse operation is to divide. Now they were left with x squared equals 4. And we ask ourselves, well, what's the opposite of squaring something? And we know that the opposite of that is to take the square root. So after they divided, their next step was to take the square root. And then just like in our do now, they asked themselves, what is the square root of 4? And they got positive and negative 2. And again, to quickly go over for number 2, we just spoke about this in the do now, but there are 2 solutions because we can do 2 times 2 to give us positive 4, and we can also do negative 2 times negative 2, and that would also give us positive 4. So right now, I'd like you to take a look at these 2 problems on the bottom of page 3. I'd like you to solve both guided practice problems by yourself, and then come back to this video to check your answers. Okay, so looking at our first problem here, the first thing I want to do is move that negative 9 to the other side. The opposite of subtracting 9 is to add 9. So I'll add 9 to both sides. I'll bring down the x squared. The 9's on the left side cancel, and I know that 0 plus 9 is 9. Now again, we ask ourselves, what is the opposite of squaring something, which we know is to take the square root. So we'll take the square root of both sides. On the left side, squaring and square roots cancel out, so we're just left with x equals. And then we ask ourselves, what is the square root of 9? Since 9 is a perfect square, this is pretty straightforward. Our answer should be plus or minus 3, because 3 times 3 is 9, and negative 3 times negative 3 is also 9. Now, looking at the second question here, 2x squared minus 64 equals 0. Again, I'm going to start by moving that 64, so I'm going to add 64 to both sides. Bring down the 2x squared, the 64's cancel, and 0 plus 64 is 64. The next thing we have to do is move the 2. 2x squared means 2 times x squared, and the opposite of multiplying is to divide. So we're going to divide both sides by 2. And we're left with x squared equals 32. Now again, we try to get rid of the square by taking the square root, since that is its inverse operation. We're just left with x equals. Now we don't know what the square root of 32 is yet, because 32 is not a perfect square. So for now, I'm just going to write plus or minus the square root of 32. But now again, we don't just stop here. We always quickly ask ourselves, well, what are those factors of 32? Now, if we list the factors of 32, we have 1 and 32, 2 and 16, 4 and 8, and I think that's it. We look to find our perfect squares, so 1 is a perfect square, 4 is a perfect square, 16 is also a perfect square, and then we focus our attention on the largest perfect square, which is 16. So we're going to focus our attention on the 2 and the 16. Again, what we do here is we come back to our square root, we split it into those 2 numbers. Again, usually easier to put the perfect square first. So I'll write the square root of 16 times 2. And I know that the square root of 16 is 4, because 4 times 4 is 16. So our answer will be x equals plus or minus 4, and we bring down that square root of 2. Okay, so at this point we are done with our guided practice. We're going to move on to our checkpoint question. So here's your checkpoint question. You can solve this either off to the side on your packet or just on a separate piece of paper. So please pause the video, go answer this question by yourself, and then come back to check your work. Okay, so to quickly go over the checkpoint question here, your first step should have been to add 243 to both sides of the equation. You should have been left with 3x squared equals 243. Your next step should be to divide both sides by 3. You're left with x squared equals 81. And last but not least, we take the square root of both sides, and we're left with x equals, and 81 luckily is a nice perfect square, so your answer should have been plus and minus 9. Okay, so at this point, we're going to get into our independent practice. So I want you to think about how you just did with that checkpoint question. If you were unable to solve for x and really you couldn't do most of those steps that I just did to solve for x, I'd like you to go back to the assignment on Google Classroom and do question numbers 1 through 6 on the Reteach worksheet. If you tried to solve for x and maybe you made a minor error, so maybe you forgot like the plus or minus sign or something else small, I'd like you to start with yellow. These problems are on page 4 in the packet. And if you got all of that right and you showed your work, you showed every single step of your work, you're going to be starting in green. Okay, what we're looking to see in order for you to get your classwork credit, if you're in red, we'd like you to do the red and get up to the yellow problems. Yellow, we'd like you to answer yellow and get up to green. And then green, we'd like you to answer green and get to those extension questions. I would really try to push yourself to get to those problems on page 5, since all of those questions there came from old Regents exams. I also just want to point out that at this point, you now know how to do 2 questions in your Regents packet. So if you're trying to be proactive and work on that Regents packet throughout the whole unit, I would go ahead and try question numbers 12 and 30 in that packet. So again, at this point in this video, you should be pausing the video, going to answer at least 2 groups worth here of questions, and then you're going to be submitting your practice onto Google Classroom. Okay, so at this point, we're going to go over the answers for this lesson. So here are question numbers 1 through 8 on page 4. Notice the difference here in number 5. In number 5, you should have taken the time to go and split that into simplest radical form. If you just kept it as the square root of 20, that would not be fully simplified. Moving to the bottom half of page 4, here's numbers 9, 10, and 11. Notice that number 10 had a little trick to it here. Here, when you tried to solve, you ended up with the square root of -4. You cannot take the square root of a negative number because no number times itself gives you a negative number. So in this case, you got an error, which is represented here. This notation here is called the empty set, which is basically just a fancy way of saying that there are no solutions for this problem. Moving on to page 5, here's numbers 12 and 13. Notice that here you start to get into questions from old Regents exams. Here's numbers 14 and 15 at the bottom of page 5. Okay, so in order for you to get your credit for participating in this lesson, you need to go back into Google Classroom and upload a picture of your work. Again, you need to at least get through 2 groups worth, red, yellow, green, and extension, in order to get your classwork credit. Obviously, you have the answers here that you could come and check your work, so you should have done that by now. Your last task of this lesson is to go back to exit ticket 8.1. This was posted last week. I also posted it again with this lesson, and please answer question number 3. You don't have to submit this exit ticket yet because we still have one more problem, but at this point you should be answering questions 1 and 2 from last week, and then now you are answering number 3.